Prerequisite tasks. There are a total of n tasks labeled from 0 to n minus 1. Some tasks may have prerequisites. For example, to do task 0, you have to first complete task 1, which is expressed as a pair 0, 1. So if we are given a pair 0, 1, then we have to first complete 1, then only we can start the task 0. So given the total number of tasks n and a list of prerequisites pairs p, find if it is possible to finish all tasks. So we will be given some pairs like this, like 0, 1, some prerequisites pairs, and we need to find whether we can finish all the tasks. So let's check the sample test cases. So here the prerequisites, n is equal to 4, p is equal to 3, and prerequisites 1, 0. So in order to do task 1, you have to complete 0. 2, 1. In order to do task 2, you have to complete task 1. 3, 2. So in order to do task 3, you have to complete task 2. So it is possible. It is possible. Now the second example, n is equal to 2, p is equal to 2. So prerequisites 1, 0. So in order to do task 1, you have to complete task 0, 0, 1, and in order to complete 0, you have to do task 1. So this is a kind of not possible one. So this cannot be done. Now let's check this example. 1, 0, 2, 1, 3, 2. So let's take that example. So we are having a task 1, and in order to complete this task, we have to complete 0. So after completing this 0, then only we can do this task 1. Then the next one is 2, 1. So there is a task 2, and in order to start this task, you have to complete task 1. Now we have another task 3, 2. So in order to do task 3, you have to complete task 2. So we can consider this as 2 vertices and a directed edge from 1 to 0, which indicates in order to do task 1, we need to do task 0. So here also we can consider this as the vertices, and this is the edge, a directed edge, and in order to start this task 2, you have to complete 1. And the same case with this one. So when we consider this as a graph, in the form of a graph, we can draw like this. Like in order to complete 1, it's having a directed edge to task 0, and we have 2, 1, and there is another task 2, which we can do only after completing the task 1, and then we are having another task 3, which can only be done when we start task 2. So we can have a directed graph like this, and here we can see that we can easily complete all the tasks. So in order to do this task, we need to complete this task 0. So we can complete this task earlier at first, then we can continue with this one. After completing with this one, we can complete this second task, and after completing the second task, we can easily complete the third task. But when we consider the second example in the form of graph, this example as a graph, we can see in order to complete 1, you have to complete 0. But in order to complete 0, you also need to complete 1. So this is forming a cycle. When we look at this, this is forming a cycle. So that's our idea. we will be building a graph from the given input, and if our graph is having a cycle, then it is sure that we will get into a loop, we will get into a cycle, and we cannot complete the task as we intended. When we look at this example, we can see that here there is no cycle. We can easily finish all the tasks. So that's the idea here. We need to find whether there is any cycle present or not. So the idea is find whether a cycle is present or not. So if cycle, then we cannot do all tasks, return false. If no cycle, then we can do all tasks and return true. So that's our idea. So now consider this example again. 1 0 2 1. So there are some methods to find whether there is a cycle or not. So we can do a DFS search, and we can find whether there is any cycle present or not. So the first thing that we will be doing is we will be building the graph, the directed graph, and then starting from 0, we will be doing the DFS, and we will be keeping track of the visited and the recursion stack. Recursion stack means the nodes that are currently processing, that is currently in the recursion process. So the conditions that we need to check is 1, if the node is already in the recursion stack, then we found a cycle. If the node is not in recursion stack but already visited, then we process those earlier, so there will not be any cycle, and no cycle. So this is the idea. So we will be doing the DFS until we visit all the nodes, and we couldn't find any recursion stack items. So as told, we will be having a visited node. Here it will be of size n, here n is 4. So we will be having a visited of size 4. This is visited. Same way, we will be having a recursion stack of size 4. So initially all values are false. This is also false, this is false, this is false, and this is also false, this is false, this is false, and this is false. And we know the index is 0, 1, 2, 3, 0, 1, 2, 3. So starting from 0, we first take this 0. We check whether recursion of 0 is true or not. Recursion of 0 is not true, it is false. So we are good. Then we check whether it is already visited. That is, we already processed it some earlier times. No, it's also false. So what we do means we change it to true in both recursion stack and in visited. Now we consider the child. Is there any child for this 0? There are no child for this 0. So since there is no child for this 0, we will move back this recursion stack from true to false. We will be making this back to false. We will be making this back to false. We will not touch this visited because we already visited this 0. We found no child, so we cannot do further DFS on it. So we will revert back the recursion from true to false. That is, we are removing it from the recursion. Now we go to node 1. So we will check whether it is a true in the recursion. It's already in the recursion stack. No, it is not already in the recursion stack. We also check whether it is already visited. No, it is not already visited. So we make this true in both recursion stack and the visited. So we make it true. Now we will consider the child. The child is this one. This is 0. So now we do DFS with respect to the 0. So when we look the recursion stack, we see that it is false. That is, a recursion stack of 0 is false because on the earlier step we reverted back from true to false. Now when we look at the visited, we already visited it, and at that time we couldn't find any cycle. So we will return false from this. So it will go back here and say it's false. Now since it doesn't have any other child, we will revert back this also from true to false. So recursion stack of 1 will be reverted back to false. Now we are going to the node 2. So node 2, we will consider the child. We will get the child. At first we will check whether recursion stack of 2 is true. No, it is false. We also check whether a recursion stack of 2 is true. No, it is also false. We haven't visited it before. So now we consider the child. The child of 2 is 1. So now with respect to 1, we will do the DFS again. We check whether recursion stack of 1 is true. No, we reverted back to false in the previous step. Now we check whether it is already visited. Yes, it is already visited. Since it is already visited, we process that node successfully. So this will return false. We couldn't find any cycle. So this was made to true at first. This also made to true since we visited. But after doing the DFS with respect to this two node, we will revert this back to false. Now we move to the next node, that is 3. Now from 3 we do the DFS. Now from 3 we check whether recursion stack of 3 is false. No, sorry, true. No, it is false. So it is not present inside the recursion stack. Now we check whether it is already visited. No, it is not already visited. So we will just make it true in both recursion stack and the visited. So after that we will consider the child. The child of 3 is 2. So now with respect to this 2, we will again do the DFS. So we will check whether recursion stack, whether 2 is already present inside the recursion stack. No, we reverted back to false because we already processed it. Now we check whether it is already visited. Yes, it is already visited. So from this it will return false, that which tells that it didn't find any cycles. So this also returns false. So the whole system returns false. So this false means it doesn't find any cycle. So since this answer is false, we can say that we can complete all the tasks. So this is the first example. Now if we consider the second example, that is this one. So same way we can draw the graph. In order to complete 1, we have to complete 0. But in order to complete 0, we also need to complete 1. So we build this graph. Now we have the visited array, Boolean array, and also the recursion stack. It is also a Boolean of size n. So this is recursion, this is visited. So we start from the 0. So we check whether 0 is also 1 minute. Let me fill it with, it will be filled with false initially. Okay. So at first we check whether it is already present inside the recursion stack. So is recursion stack of 0 0 is true? No, it is false. Okay. So we already visited it. No, it is not already visited. So we make both of them to true. Both of the values are made into true. Now we can consider the DFS with its child. Its child is 1. Now we check whether 1 is in the recursion stack. No. We check whether 1 is already visited. No. So we make both true. This also made into true, and this is also made to true. So now we completed it. Now we will consider the child of 1. The child of 1 is again 0. So we will do DFS with respect to the child, which is 0. We check whether the 0 is inside the recursion stack. Yes. When we check the recursion stack, we say that 0 is already inside the recursion stack and we haven't processed that node completely successfully. So since this is true, we can say that we find a cycle. So we can return true here. Since we return true, this means that a cycle is present. So we cannot complete the whole task. So this is the whole thing that we need to do here. So let's try the code. So if the length is given as 1, just a pre-check, that is only 0 1, that is in order to complete 0 you have to complete 1. It is possible to do that by completing 1, then we can complete the 2. So we can just return true here. Now the next step, we need to build the graph. So the next step is building the graph. For that we can use a list of integer graph, which is equal to a function build graph using and we can pass n and prerequisites. Now we need to make use of this function build graph. So let's complete that build graph. So private list of integer build graph of int n and int prerequisites. Now for each of this n means, what is this n? It is the task. So that's the vertices of for all this. We will be creating an array list. So let's have a list of integer graph is equal to a new array list, and we will be returning this graph. So this is a directed graph. This will be a directed graph. So for each of the nodes, for int I is equal to 0, I less than n, I plus plus, we will be allocating a space, that is we will be adding a new array list. Now for each of the tasks or the I am just shortening it from prerequisites, we can make a directed edge from 0 to 1, that is from 0 to pre of 0 to pre of 1. So that is done by graph.get of pre of 0 dot add of pre of 1. Since we created array list for each of the node, the graph will, a directed graph will be generated and this graph will be returned. So now we have the graph. Now what we need to do means, we need to check for the cycle in the graph. If we find a cycle, we can't finish all the tasks, so return false, else return true. So return not is the cycle of graph. So is there cycle will be returning whether we find a cycle or not. So is there cycle will return true if we find a graph. So if we find a cycle, then it means that we cannot finish all the tasks, so we need to return false. So that's why I added a negation. So whatever the answer I got from here, the opposite of that will be taken. Suppose is there cycle returns a true, that is found a cycle, then its negation, that is false, will be returned, which is what we actually needed. So now let's implement it. Is there cycle of list of integer graph? And since I told that we will be using two boolean arrays, visited and recursion stack of size n, we also need to pass that size, int n. So int n. Now as told, we can create two boolean arrays of size n. One is visited and the other one is recursion stack, which is also a boolean array of size n. Now from 0 to n minus 1, we will be doing the DFS and checking for cycle, checking for whether there is a cycle or not. So for int I is equal to 0, I less than n, I plus plus, if DFS cycle detect, we will be using a DFS in order to detect the cycle on the graph for the node I, from the node I and visited and recursion stack. So if this returns true, we will return true, otherwise we will return false. So this will return true or false if we find a cycle. So if we find a cycle, our main isPossible method will return false. If there is no cycle, it will return true. So now let us implement the DFS cycle detect function. It is having a graph. It is taking a graph as a parameter, a node, then boolean visited and boolean recursion stack. So first, as I told, I will be checking if the node is already in the recursion stack. If the node is already inside the recursion stack, then it means it is already in the recursion path, it haven't processed completely. So there is a cycle that we reach again that node again, a previous node again. So if recursion stack of node, so if it is true, we will return true, that is we found a cycle. Now the next one is if the node is not in the recursion stack but it is already visited. If it is already visited and if it is not in the recursion stack, it means that there was no cycle before when we process that particular node. So we can return false. So if visited of node, we already visited the node, then we can return false, as we already gone through this node successfully and no cycle was detected. So now since both of these conditions fails, this is a fresh node, so visited of node can be made into true. Recursion stack, we can move this into the recursion stack and it is also made to true. Now we need to consider the child of this node and again do the DFS with respect to that child. So let's take all the children from the graph.get of this node. Now it will get all the children, a list of all the children of that node. Now we can iterate through each of these children and continue our DFS search. So if DFS cycle detect of graph, now our node is child, visited and recursion stack, then we can return true, that is there is a cycle. Otherwise I told that we will be reverting this back from true to false. So recursion stack of node will be reverted back to false and we will return false. So this is the whole problem. Now let's check, is there any compilation error or is it running fine. Recursion stack, I misspelled recursion stack, yes, I missed a R. Then is there any other? Only recursion stack, okay. So for the first test case is returning yes, yeah, that was what we intended. Now n equal to 2 for the second test case, now we need to get no, as there was a cycle. So let's check whether we are getting it correctly. So that's also returning no. Now let's submit it. Yes, it's successful. So the time and space complexity will be big of v plus e vertices, where v is equal to the vertex and vertices, e is equal to the edges. So we are just doing the DFS, we are making use of DFS, and we can also make use of the BFS, but here I use the DFS.